Now, the last part is the mathematical part of it. Convert that into a hypothesis testing model. Okay, the moment you say you take a question and you convert that question into a predictive one, you should also create a hypothesis testing to say that I change parameters or features as we call them for 5 and 6, I get results like this. And it should be done via independent experiments that it can be proven. Right. Now, after all this comes the question about what should be the architecture and where should be the data from. And this part is very important because one of the classic mistakes, in fact, it's a very common mistake where people come and say, oh, so I have this big data lake and I fill that lake with all this data and throw in whatever more buzzwords you want to add to it, right? I have all these things. Now let's think about what is actionable insights or whatever insights I can gain from that. That's a wrong way to probably do it. Although I've done it myself, right? I won't recommend it, but I've done that myself and I've learned from it. I still keep doing that mistake once in a while because sometimes we have the data and we have to do something about it. But the ideal way to go would be to ask the questions first and then come back to the technology. And that's exactly what we'll do in our example as well. Lastly, really talk about what's actionable insights from it and how can I put that to use. If you can't implement it or if you don't find value in it, it might be predictive, it might be prescriptive, but there's no point in having those insights. Okay, so with that now, it's very abstract as of now, and what I'll do now in the next 8 minutes is actually to walk through a real example where we have used this process so that I make it a little more real to you. I make it, and I've chosen as much of a low-tech example as I could find, and that's for a very specific reason. In fact, I've chosen farming, which is a very simple use case. I've chosen that for 2 reasons. Number one, I have just about 8 minutes in which I can explain that to you. Right, so I wanted to make it as simple as possible in terms of if I choose a financial one or a product-based one, to start with, we'll have to start with understanding the technology or the domain behind it. This is very simple. We can all get that just like that. The second one is that to explain the process, it's important to have something with the simplest goals as much as possible, and this is one. So with that, let me. I cannot talk about the company, by the way. So this is a project that we have done a few quarters back, which were successfully implemented at a customer's place, obviously to the client confidentiality and other aspects. I don't want to talk about the company, but let's talk about it. The problem is predicting crop yield with machine learning and big data analytics. Okay. Now, specifically, we are talking about sugar production. Okay. In terms of sugar production, the number 1 country in the world in terms of sugar production is Brazil. Anybody knows the number 2? India. Yes, exactly. So number 2 is India. Okay. Now, the company that we are talking about is in the United States. Now, again, as I said, want to engage the audience. So, question now is that what's common in India and Brazil? Excellent. So, it's a tropical climate that's actually, it's very much needed for sugar, right? It's that's why it's India and Brazil are the most, the largest countries producing sugar. Where do you get that kind of climate in United States? So, sorry? One is Florida, which is the most obvious thing that comes to mind. The other one is Louisiana. In this case, you're talking about a company which is in Florida, and let's start the process, right? So, step number 1, what are the questions to ask? Who are the business stakeholders? That one is pretty simple, right? You are doing a business, you are doing something for a company. The most obvious answer is that all the CXO team, preferably the CIO, preferably the CEO. But we are also saying CIO because in the end, being an IT product company, CEO is a major customer for us, right? So we go and ask them, what's the next question? What's the key business initiative? What do you want your data analytics to do? So they're like, we want to generate more money. Yeah. Don't everyone wants to make more money? So we have to make it a little more real. So how do we make more money? One of the most obvious ways to make more money is to say that if we can improve the crop yields using data analytics, right? So that's the most obvious example, and that's exactly what we want to do, right? Understand how we can generate more crops using big data analytics. So I talked about I-shaped skills and I talked about the broad skills, right? So let's assume that now we have, and actually we do, I take particular pride in my team. We have the I-shaped skills. We need to understand now the T-shaped one. difference, right? So we need to really understand the domain. So we are in the sugar domain now. So what works for sugar? In the interest of time, I just have 6 minutes, so I'll just quickly run through it. It's pretty obvious, you can see that, but it takes a little bit of time before we see the yields, right? It's about 10 to 12 months before we see the yields. And this part is very simple. So we did some Google Analytics. We also talked to some members from the community, from the company who are farmers, who have been career farmers, dads and granddads and stuff like that. So been there for a long time. We asked them questions. We figured out what has to be done. And then we started with the process of identifying the right decisions. So what are the right decisions? Number one, provide an accurate prediction of a farm's yield. And that's used for two things. Number one, to obviously take out those data, take up all those information and to do the right stuff so that your farm provides more yield. But as a farming company, they're also interested in harvesting other farmers, right? So there are farmers, they go to them and say, hey, let's harvest your sugar farm for you. And this is the quotation that we are giving you, right? So they also need to understand what is the right strategic acquisitions to make based on the information that's provided by this. That's the second one. So with that, we created this again as a mathematical part, and we'll skip that. I don't want to bore you guys, but I'll be more than interested in talking about them if anybody is interested in it later. We developed a precision agriculture model, and these are basically, like I said, experiments that we do to say that, for example, a tropical climate, you need rain, right? Based on, if I say that rain is a feature and this much rainfall is required to have a great yield, how can I test it in isolation, right? How can I run isolated experiments to verify that data? So that's one of the things that we did. So again, this is something, this is an interesting slide, and the last time I did that, I actually asked people questions and said, what do you think are the features that actually improves a farm's sugarcane yield, right? We don't have time for that. We just have 5 minutes, so I won't ask that. But one thing I've found is that sometimes the features are very obvious with the data that we talked about just before and the slide that I put for sugarcane. Most of you guys would have predicted this. The only other addition that we added in terms of satellite data is that NVDI and NVDI and NDWI. One is a water index, which says that how much water content the farm is getting. The other one is a vegetation index, normally differentiated vegetation index. It's basically satellite image, which says how thick the field is, which gives us an indication that how much plants are growing there. Okay, the rest should be pretty common, like IoT sensor data. There's a lot of these things like tractors, and there's small sensors which is there in every other square kilometer. We pick up all this information, including average temperature and hundreds of other things, right? Obviously, we have soil data, we have weather data, fertilizer data, and farm details. And there's obviously the usual suspect, as I said, the most relevant, one of the most relevant predictor of future yield is the past yield. So that's there as well. And we'll build a system. Again, the technology, I won't go crazy over it, right? We used, in this case, as you can see, a lot of SAP, because this was provided to the customer over one of our hosted enterprise cloud called as VirtuStream. And VirtuStream it's not a public one, so you can't take a credit card and go and sign it up with like AWS, but it's for enterprises, and they are high performance enterprise hybrid clouds, which tries to optimize your mission critical SAP applications. So that's why you'll see a lot of SAP there, apart from the Hadoop, the Hortonworks thing that we use, but it can be implemented in any other things. This worked out particularly well for us. On the left side, you'll see all the file sources we use. Some of them are really, really big files, like satellite images. They've come in terabytes. And to do that, sometimes we'll have to use HiPi, which is the Hadoop image processing interface. Because if you just store it as regular files, then processing them on the fly using something like an OLAP on Hadoop is very, very complicated. Okay? And we created a model which very accurately, in fact, close to about 90% accuracy, we predicted that. Well, again, I'm a big believer in keeping things simple, and one thing I'll tell you is that we found that random forest is almost as good, right? About the accuracy was about 86%, and for something which is so easy to explain, like random forest, compared to, I think the top one was AdaBoost. Obviously, from out of the box, it gave us about 88 to 89% accuracy. Finally, we had a bag of models, and that gave us close to about 90%. But we are really here for the last question: what's actionable insights? So there are about 100 different parameters. I didn't mention all of them, but I did show about 20 of them before. These are the top 3 which impacts and can explain a crop's yield: the maximum amount of daily rain for a season, the previous year's yield, and average normally differentiated water index, which is actually tied up to the rain and lakes and all this thing, right? So, but here's a problem, right? We started with the original process that by predicting this or by understanding what are the features behind this, we should be able to predict very accurately, or we should be able to do something about it. Actionable insights, or so we called it. In this case, there's hardly anything that we can do about it unless we can do something to change the rain gourds or something like that. There's hardly anything that we can do to improve a crop's field. So did we fail? So I said one more thing, which is understand what's the right strategic acquisitions, right? Understand one of the things that they were doing is harvesting other farms. And to do that, you need to really understand what's the right, what's the right cost for this particular farm. This is not the best representation of the data. That's Florida EAA, Everglade Orchards. Again, the company name is not there. And it shows the various farms in that area. This is again not the most intuitive interface that you see. The client is always right? And most clients would like to have a geospatial map with some dots on it. They like that. But a tabular form where they provide, we rank all the farms which are available for harvesting, and we talk about what we call as the PCA, right, the prime cost of acquisition, and a lot of other details. It shows them what's the right strategic farms to acquire. And it provided them with a significant improvement in performance in terms of processing an order or an offer. If we went from 48 hours to 20 minutes. The accuracy was about 60% when done manually. We went from 60% to 90%. Of course, it enabled a good business strategy. I'm at the end of my session. I hope it was useful. I don't have, unfortunately, time for questions, but hopefully this being the last one, I will stay back, and if there are questions, I would like to take them. Do you have another 2-3 minutes, or I'm done? Okay. Right, and I'll be around if there are questions. Thank you very much, and it's been a pleasure being here.
So we have time for 2 questions in case you'd like to take on stage. Any questions? If not, then thank you so much.
Hi, I have a question.
I'm sorry, yeah.
Okay, somebody there?
So, referring to your 6 skills slide, and coming back to the Indian context, as to what kind of a student can be a data scientist, what kind of a student can be a data scientist.
Okay.
I'm forced to believe that a graduate, an engineering student, would be more suitable to become a data scientist as compared to, let's say, a postgraduate or an MBA student. I just wanted to verify this basis the 6 skills that you showed.
I wouldn't necessarily say that. I would say it's a personality trait. The real question that you should ask yourself is that, am I scared of maths, or am I okay with maths? Right? The second question that you should ask yourself is that, am I ready to learn, and am I ready to experiment? Am I ready to get my hands dirty? Do I like doing this thing? And if most people can say, the wrong reason to pick up data science, for example, is because it's a buzzword and people get paid well for it, right? The right reason to do that is that sometimes I can be geeky and I can go a little deep and I can get my hands dirty, I can read stuff, and I can understand what's happening in the industry. I won't necessarily look at a qualification as an additional benefit, or even, for example, I can say just because a candidate is, having a PhD in maths is more suitable versus an MBA who is less suitable. It all depends on the person's interest. And remember, we did talk about the T skills, so it's not just about going deep that matters. It's also about understanding the domain and how people are going to use this data.
Thank you.